Hi, and welcome back to educator.com. Just kidding. This is Dr. Graham, not Dr. Sun. I am going to record a very brief video showing how to run the descriptive statistics and the regression model that is used in doing the classwork for 5.1, which is where we were building a model to predict price of pizza based on number of toppings. So this demonstration will be very useful for understanding what is covered in our first exam, and it will be very useful for those of you who may have missed class on 5.1, so week 5, and hopefully it clarifies a few things along the way. Okay. So I'm not going to do the entire thing, but just want to show. So here we want to build a simple model about price of pizza, and we're not including anything else. We're not including toppings yet. We just want to know, based on price of pizza, what would be kind of our best guess. So the very super duper simple model that we start with is data equals mean plus residual. Okay. So if we want to find the mean, here's my pizza data set. Let me just move it over here. I'm going to go analyze, descriptives, and explore. I am interested in the price of pizza, so that's my dependent variable. I only want to see statistics and click OK. And here we go. So we can easily see the, the mean is the very top number, 14.1194. So our mean here, just for those following along, is basically 14.12. And our standard deviation is listed below. If we go down here, we can see about halfway down, it is 4.18351. I'm going to round that to 4.18. Okay. So then we could use that to make our model super quickly. We could do, here's the shape. Let's see, 14.12 is around here, so right through here. My shape's a little off, good enough. This is our mean equals 14.12. And then I could show my standard deviation. Let me just show this here equals 4.18. Redo that, undo. Okay, so that shows our shape, our center is our mean, our spread is our standard deviation, and then we could do our super basic model where we're saying basically price equals the mean plus residual. Okay. All right. Now for the second part, let me just clear all this out. If you need it still, you could rewind the video. Okay. So down here, if we look at this scatter plot, we are creating a better model, right? By adding information that's hopefully relevant to what we're trying to predict. So in this case, we are using toppings down here to predict price of pizza. So keep in mind, whatever is on our y-axis up here is our dependent variable. It's what we are trying to explain or trying to predict. And the thing down here on our x-axis is our independent variable. So in this case, we think that we can use toppings to predict the price of pizza. Okay. So look at it. You can sketch the center, which in this case is more like something like that. We can sketch in some of our residuals, right? That's just the difference between the line and our actual data points. Okay. And we said that our dependent variable is the one on our y-axis, so this means that our dv is price of pizza. And our independent variable is toppings. Excuse my sloppy writing. Then we want to connect our formal notation, which is this right here. That's the formal notation for a regression line, with the modelese, the language of models that we read about in that chapter about building models. So when we very first started talking about models. So that's sort of this kind of concept here, right? So dv equals some constant, and I am not providing myself enough space, so let me move this over. Okay, so the dependent variable is equal to a constant plus effect of the IV plus residual, which is basically just like error, everything else we haven't accounted for. And so you'll find this modelese on the last page of that chapter section that I handed out for everybody to read in class about models. So to connect this, this basically is showing us that, well, let's do something fancy. Let's go gold. Okay. So this y is our dv. That's why it makes sense to put our dv on the y-axis, right? This b naught is our, okay, got a little lag time there, is our constant. And this part, the b sub 1 times x, x is our independent variable. Right, so this part is talking about the effect of the IV. You'll notice we don't have anything in our regression line to cover the residual, right? So in this case, when we're building a regression line, the residual or error is just implied, right? So we don't actually include it in the formal notation, but we do include it in the modelese when we're talking about generally what the model looks like. Okay. So I have this table here, which we can use to fill in some pieces on our regression equation. And quickly, I want to show you how did I get this table. So to get that table, I go into SPSS and go to Analyze. We have one very clearly labeled regression. In this class, we are always doing linear regressions. So now we need to say, what is our dependent variable? What is our independent variable? We decided up above, dependent variable is price of pizza. So let me grab that and put it in dependent. And independent variable is toppings. So grab that and put it where it says independent. There's all sorts of other stuff we could do in here. We're not going to mess with that. We're just going to keep it basic. Click OK. So you'll see that the regression analysis spits out a lot of information. So we have the very first table, which just clarifies our dependent variable is price of pizza, check, and the variables entered in our model, toppings, independent variable, check. This model summary we're going to come back to. ANOVA, we're just going to skip this table entirely, right, for now. And lastly, we have the coefficients table. We do need information from our coefficients table, which is why I provided it right here. You can see these numbers match exactly. All I did was copy and paste it in here. So from this coefficients table, we can plug in the b sub 0 or constant and the b sub 1, which is our slope. So where do we find that information? It is right here. So to be more clear, let me highlight these in two different colors. So our constant will surprisingly be the one, make this a little smaller. Surprisingly, it's the one that's labeled constant. Wow, look at that, fantastic. So that value is what's going to be plugged in right there where it says constant, 9.512. And the other value we need from this table is right here. So the B sub 1, we see the B, and then sub 1 is referring to our one independent variable toppings. So then we can put this in, 0.993. You can put the 0 or not. Just make sure you get that decimal in there. And then don't forget, put your x, because that represents our independent variable. So now our whole regression line, if you can read my writing, says y equals 9.512, our constant, plus 0.993x, where our y represents the price of pizza and our x represents how many toppings. Okay. So we could also say, if we wanted to be a little more specific, we could say price of pizza equals 9.512 plus 0.993, and then we're going to put toppings in instead of x, since that's what it represents. Now when I say interpret the meaning of these numbers, what I mean is I want to know, what does this tell us about our scenario? What does this tell us about our scenario? So if we think about it, if we plug in 0 toppings, then this whole thing, 0 times 0.993, turns into 0, right? Because 0 times anything is 0. So then 0 plus 9.512, this means our pizza with 0 toppings equals $9.51. Now this part right over here, this 0.993, this is telling us that for every topping we add 0.993 to the price. So if we had 1 topping, we would add basically 99 cents to this, and our pizza would cost $10.50. If we had two toppings, add another 99 cents. Now it's up to $11.49. Okay. So we can interpret the constant that's equal to whatever the thing is we're predicting when our independent variable is set to 0. The number b sub 1 that's associated with our independent variable, that's the effect of that independent variable. That's our slope. That's how much our dv is going to change if we change our IV, right? Add 1 topping means add 0.993 to the price of the pizza. Okay, so we're going to skip G. You could go back to the scatter plot and, change your line if it's actually crossing at the wrong place or your slope is a little off. We're going to skip that. This next part, the interpret the correlation. Right, so now we see this model summary table, which we got from over here. Right, same numbers, once again, just copy and pasted. So this explanation down here is sort of telling you about this r squared value right in here. So you can think of this as a way of looking at how good our model is. And you think of it as ranging from like 0% is a really bad model, 100% is a perfect model, right? And you really need to think again about, why do we have a model in the first place? What are we doing? We are trying to, let me see if I actually wrote it up here somewhere. Hopefully I did. Can't see, but we're trying to predict or explain the variance in price of pizza based on a model that includes number of toppings, right? So what this number is telling us is, it tells us what percentage of our variability in pizza prices is explained by our model that includes toppings. So if we think of this as a percentage, this is 35.3%, which means that we are explaining about 35% of the variability in pizza prices with our topping model, right? Using toppings to build a model to try to predict pizza prices. So this 0.353, we're explaining about 35% of that variability. This means that how much have we not explained? About 65% not explained using our model. So this is 65% of the price of pizzas, right? Of the variability in price of pizzas comes from other stuff. That's the idea of that, unexplained error. So it could be the quality of the ingredients they're using. If they only use non-GMO organic materials to make their pizza, probably the pizzas will be a little more expensive. If we haven't accounted for the location, if it's a wealthy area, maybe we expect the pizza to cost a little more. Maybe some are pyologies where it doesn't matter how many toppings you put on. Maybe some are Domino's, maybe some are gourmet pizza shops, right? So there's all this other stuff that goes into how a price of a pizza is determined besides just the number of toppings. But our model, where we use the number of toppings, tells us about 35% of it, right? So there's about 65 other stuff, but our model accounts for about 35%. So hopefully that clarified a few things and shows you just the very basics of how I got these tables that you see in your classwork and in exams and so on. It's easy to get through SPSS. So any questions, send me an email or drop me a note somehow.